guys, so today we are going to learn about number 38. We are going to solve our systems not by using Desmos on the calculator. We are going to use it by using algebra. So remember that solving a system finds us a solution, and the solution is the intersection point that we write as an x comma y, a point on the graph. So in order to solve these by algebra, first and foremost, you need to make sure that your equations are in standard form. So since these equations are already in standard form, to help us find the solution of the equations, we are going to look to find which one of these variables or letters can I get rid of, or we call that eliminate. So when we look at this, x and x are both positive, but I have a positive y and I also have a negative y. That positive-negative pair will end up meaning I have no y's, which ends up eliminating the y variable. Hence why we call this elimination. Now, when you eliminate, then what you're going to do is add the remaining pieces. So I have two x's that are left. So 2x equals 10 plus 2 is 12. And I'm going to solve for x by dividing by 2. 12 cut in half is x equals 6. We're halfway there. So we need to make sure that we get our second portion of our solution, guys. We have our x, but we don't have our y, and that's what I need to find. So to find y, guys, we have to use one of the two original equations. Most of you will always use the equation with less negatives, which I don't blame you. It makes less mistakes. So I'm going to use x plus y equals 10, but in place of x, we're literally inserting in x's place what we found x to be, which is 6. So we have 6 plus y equals 10. To solve for y, we have to undo the positive 6, which means we need to subtract by 6 to finish our mission. So we've got y equals 10 minus 6 is 4. So our y coordinate of our intersection point is 4. So our solution is 6 comma 4, x comma y. All right, now let's try another one by elimination. So right away in the second question, I see that I can eliminate x. So that's who I'm going to get rid of, my positive-negative pair. And now we're going to add who's remaining. So we're going to add this up. So 3y minus 2y gives me 1y. And negative 1 plus 2 is positive 1. We're going to divide by 1, and we end up getting y equals 1. We're halfway there. We need to substitute our y in place of one of our equations. It looks like I'm going to probably use equation 2. So in place of y, we are going to insert that y literally is 1. There is no y in the equation anymore. We're replacing it with its number, and we're going to multiply that. So negative 2 times 1 is negative 2. Now to solve for x, we end up having to not subtract by 2, but add by 2 on both. And 2 plus 2 gives us 4 as our x coordinate. So our full intersection point is 4 comma 1, x comma y. All right. Now, I want you to take a look at number 3. This guy's a little bit different than all the others we've looked at. So what is different about this problem than all the others we've done? Well, I do see a positive-negative pair in the y's, but I don't see the same number in. But we do notice that both 4 x's are both positive, which is a good thing, and they also have the same number in front of the x. They both are 4x. So to change this equation to help us eliminate, we need to make a positive-negative pair first, and we need to make sure the number in front of the letter is exactly the same. So this is how we're going to complete our mission. So if we don't have somebody that eliminates right away, we force it to eliminate. So in order to do that, guys, I notice that I do have the same number in front of x. They're both 4 x's, but one of them needs to be a minus. So to force it to become what we want, we choose one of those two equations and we force it to become negative. Now we're going to rewrite that new equation. So the entire second equation, the 4x is now minus, the 5y is now minus, and the 14 is now minus. Now we're going to keep the same first equation on purpose. So the reason why we keep the same first equation is because now, since we changed the one of those 4x's to be minus, they now eliminate, which means now we can add the rest together. So negative 3y minus 5y gives us negative 8y's, and negative 2 minus 14 gives us negative 16. We're going to divide by negative 8, and 16 divided by 8 is positive 2. All right, now since we're halfway there, we need to find our x. So I chose to use the second equation, and in place of y, we are inserting our 2. So 5 times 2 is 10, and so now we're going to solve for x. So instead of adding by 10, we take away by 10, and 14 minus 10 is 4. And now we're going to divide by 4, and we end up with x equals 1. So our solution to our system is 1, 2. All right, so let's try the next one. So I'm noticing that I already have a positive and negative pair, but we have a problem because it doesn't have the same number in front of x. So that means we need to multiply the first equation by 5, so we get a negative 5x so that we could eliminate. So notice we take the 5 and multiply it to every single piece. So our y now is becoming a positive 5y, and our equal to 3 now becomes 5 times 3, which is 15. Now we're going to keep the second equation. We keep that because now we have a positive 5x minus 5x. That eliminates, and now we can add together what's remaining. 5y's plus 1y makes 6y, and 15 plus 9 gives us 24. To get y by itself, we divide by 6. So our y is 4, and now we need to find x. So I'm going to use the second equation. We're inserting 4 in place of y. To solve for x, I need to subtract. And to finish, divide by 5. So our solution is positive 1, 4, or x, y. Try one more with me. So I'm noticing I already have a positive negative pair, which is y, but they don't have the same number in front. So our goal is going to be to force that to be the same. So what is 2 times 6? 2 times 3, I meant, which is 6y. So to make a 2y into a 6y, we need to make that multiplied by 3 for our top equation, which ends up giving us 15x minus 6y equals negative 57. And in our second equation, to make a 3y into a 6y, we need to multiply by 2. And now we write that new equation. We end up with 4x plus 6y equals 0, which means that I do end up eliminating my positive 6y and negative 6y. We add our remaining pieces, so 15x plus 4x is 19x, and negative 57 plus 0 is negative 57. Let's solve for x by dividing by 19. So x is negative 3. We're halfway there. Ah. So now we need to find our y. Pick one of those two equations. I'm going to choose the second one. Inside of that second equation, I substituted in negative 3 for our x, and now we get 2 times negative 3, which is negative 6. To solve for 3y, I need to not subtract by 6, but divide by 3, and we get a final solution with y equals 2. So our solution to our system is negative 3, 2 as a point. So our new method is called solving by elimination because we're eliminating a variable. So when you're solving a system of equations by elimination, what are we finding? Well, we are finding that point of intersection, that x, y. If we graph, substitute, or eliminate by solving a system, will they all find different solutions? Since we're finding the intersection point from all of those different methods, this answer is false, because they should give us the same crossing point. Letter A is not in standard form, so therefore I would graph that using Desmos. Now letter B is in standard form, and I could eliminate the x's right away. So this guy, I would use the method of elimination. Letter C is also in standard form, which means I can use eliminate, but we'd have to subtract one of those, like, or make -3y to help us eliminate. Or we could, if all else failed, graph it. So you could use either method on C. And same thing with D. You could eliminate, but you'd have to do a little work, or you could also graph that. All right, guys, so it's time for you to practice elimination. What would help me eliminate the X or Y?